Okay, again, we're going to go through standard deviation, z-score, standardizing, correlation coefficient on Excel the very, very easy way. The first thing we want to know in order to find standard deviation, stuff like that, is we usually need to know the mean, okay? So if I need to find the mean of all these values, I could go about summing and stuff, but really I can just do is equal to the average. Average is the same as mean. So I do an average function, okay? So we look for the average of this row here. It gave me 34. I think that's right. Yep. And then the average of our other row here for calories, 455. Yeah. So those are our two means. Really simple. We just type in average. So I actually didn't even write mean in here. I'm going to right now. So if we're looking for mean, the function we use is called equal to AV. Right? Average, yeah. Okay, so that's the function we use for that. Average equals and then the values or the array of values. Okay. Standard deviation. Let's say we wanted to find the standard deviation of the first set here. Well, standard deviation is equal to ST, and it's standard P. Okay. Standard P is what we want to use, and I just highlight all the numbers in our row. Okay. So STDEV.P.
Does that have to do with proportion, P?
Has to do with an entire population.
Oh, population.
So it's the standard deviation of the whole population.
Oh, okay. That makes sense.
Standard deviation is 6.1 for the first one. For calories, we do ST deviation P, right? And the array of numbers, also all these terms. Standard deviation is 29. Okay, so for standard deviation, we'll do him in black here. He's equal to ST DEV dot P. Okay, let's just double check that was the exact one. Yeah, ST DEV dot P, and then we write our array of numbers from where to where. Okay, so those are our two standard deviations. Those are already done. Correlation coefficient we can actually do really quickly. Okay, correlation coefficient equals COR, Correl. Correl is what we're looking for, and it says array 1 and array 2. In other words, you have to get in a whole array of numbers. Remember, because it knows it has to divide two terms for correlation coefficient. So we take the array of our x values and the array of our y values, and we get a negative 0.656. Okay? You okay with that?
Mm-hmm.
Yeah? Okay. So, in other words, correlation coefficient can all be written as one thing. We put equals CORREL, and we just put our values in, and it's going to give us our correlation coefficient. Okay. For standardizing, equals standard. Now look, it's a big word. We actually have to put in the word standardize. And then it tells us what we need to put in. We need to put in the actual, see that X means the first set of data. So let's say we're trying to standardize this. Here's our first set of data. Bracket. Well, the mean. The mean is this guy here. Okay, and we could type that value in if we wanted. Comma, the standard deviation. Well, we already found the standard deviation. Okay, and that has standardized the first one. Okay. Right, and now we'd have to do that for all of them. So normally we would copy this. Okay, yeah. I'm going to show you the fast way again. So standardize. We still want this value, comma. We want our mean to always be the same. So in other words, we need what values here?
Oh, the number, the dollar sign.
We need those dollar signs. So that means if we copy this function, it's always going to take the mean from there.
Oh, okay.
Okay, right. And our standard deviation, again, we need to be the same. So we're going to put dollar signs. Okay, dollar sign, boom. And there's the next one. So now I can just copy this, Control C. And everything has been standardized for the red ones. Okay, really easy. And I'm just going to highlight them in the color we did. That was the red. These are our red answers to our y values. Okay, sorry, our x values. And then for standardizing the y, we do equals standardize again. We take this value, and we're going to do the same thing. The mean here, but I want it to be dollar signs, right? Because we always want to take from that exact mean. We don't want it to go down as we go down. And then the standard deviation, which is this guy here. Again, we need the dollar sign. Standardize the first one, and all we got to do is copy, Control C, paste, Control V. And then these are the standardized value of all the blue ones. So here's all of our blue our mean. And the correlation coefficient is together, always, okay? And now, technically, I was looking for z-scores. I think it has to do with normal distribution. I'm just going to write what you type in here. For standardizing, we push I think it's standardize. And then technically, it's the value, the mean, and then the standard deviation. Those are the values that got to go into this bracket here. Okay, that's what we have to put. And again, z-scores, I think there's a normal distribution, but I couldn't quite find it. So one of the best ways is maybe to do that x bar minus the standard deviation. So we would just kind of x bar everything. So in other words, our z-scores are equal to the data minus the mean, and we're going to put these in brackets because we'd have to do this first. And the mean here is 34. And again, because we want that mean to be the same every time we dollar sign it, but we're going to have to put a bracket around this. I'm pretty sure there's something with normal distribution to do, but it's fine. And then, so that's what it's doing, is taking the data subtracted by the mean, then it's dividing, the standard deviation. Hi. Dollar sign.
Just go tell her we're recording.
Yeah.
Katrina?
We're downstairs.
And that does the z-score for that one. And all you have to do is copy and paste. And those are all the z-scores for the pink one. And you would just repeat the process for the other one. Does that make sense? Yeah. Okay. 7 minutes. Not so bad.